Okay, Unit 2, free response, numbers 4, 5, and 6. These are derivative problems, so be aware of product rule, quotient rule, and such. The first problem is let f be a continuous function. Here's the graph, -1 to 8. The two line segments, they're specifying line segments. G and H are the mentioned functions. If k is defined as k of x equals f times g, find k prime of 0. So our solution is we need to use the product rule here. So before we evaluate at 0, we have f prime times g plus f times g prime. So there's our product rule right there. All right. F prime of 0 from the graph means what is the slope of this function at 0? So we count up 2 over 1, slope of 2. That's what f prime of 0 is. G prime of 0 we get from our calculator. Now we are required to round to 3 decimal places, but in this case, because we're using it in the problem, we want to keep it as expansive as we can. Okay, so now that we know what f prime of 0 is and we know what g prime of 0 is, we just evaluated every one. F prime of 0 times g prime of 0 plus f of 0 times g of 0, and then this is our answer. And because this is and then it's just a matter of plugging it into our calculator, and we get 2.598. And that's where we round to 3 decimal places. Okay, the next 2 problems. Part B talks about m being defined as m of x equals f of x over 2g of x. Find m prime of 5, the exact same problem, except instead of doing the product rule, we're doing the quotient rule. The derivative of the first, normal second, that includes the 2, minus the derivative of the second, which is 2g prime, normal first, all over the second squared. Notice the 2 is inside the parentheses. Then from here, we evaluate this at 5, m prime of 5. We again go to the graph, all right, to evaluate the 5, which is simply the slope of this line at 5 right here, which is negative 2/3. And then we do the same thing with g prime of 5 with the graphing calculator, and we have just evaluated. So we put the formula together first. We find out what f prime of 5 is. We find out what g prime of 5 is. We plug it in, and once again, we round to 3 decimal places. In this particular case, in the part C, it says find the value between -1 and 2, again, not including where f prime equals h prime. Well, again, f prime from -1 to 2 throughout is equal to 2. So that's the first thing we know. That entire line has a slope of 2. H prime of x, the derivative of the function, is 5ex minus 9 cosine. So the derivative of sine is cosine. The derivative of minus 9 sine is minus 9 cosine. We set the derivative equal to 0. We will do this on our calculator. Of course, we're not using our calculator. So what we would do is we put this into the calculator and y equals 2, and we find out they intersect at that point. Okay, so for number 5, we're given 2 graphs. We're given f and its derivative. Let's first make sense of the fact that we don't need to do this exactly, but just to understand what's going on. This has a positive slope up to there. This goes negative. This is a positive slope to there, which means these are going to be positive values all the way to there. And then once we get beyond there, it's going to be, this is the peak of the curve. It's going to be negative. And then at this point right here, it becomes a linear function. This piece right here has a linear slope. This has a linear slope. So right here, this piece coordinates with that, corresponds with that. And this piece right here corresponds to that. And this whole part of this graph, let's just do this first part. That first part right there is going up the whole way. That right there is going up. At that point, it becomes negative. Below the graph, it becomes negative. All right, so that's the first part. The average rate of change over the interval. The average rate of change is simply f of 4 minus f of -1 all over 4 minus -1. So this is our process right here. This is our average rate of change. How much the graph changes from 4 to -1. Okay, I can go either direction, and I find it to be 3/5, which makes sense because we're talking about this change right here. Okay, this, how much this changes about from there to there. And then it says, does the instantaneous rate of change of f equal the average rate of change in an interval? Well, this is the instantaneous rate of change. Therefore, when does this equal, get that out of the way, when does this equal 3/5? That's our question, all right? And this equals 3/5 right here, and it equals 3/5 right here. In other words, just wherever it crosses that dotted line, and it crosses that dotted line twice. So the instantaneous rate of change of f equals that for 2 values. They do not ask for those values. They just ask for how many times. So, does the instantaneous rate of change equal the average rate of change? And the answer is twice. All right. B, write an equation for the line tangent to the graph of f at x equals 1. So when we're talking about tangent to the graph, we need n, and we need x, and we need y. So in this case, our function at f of 1, to evaluate the function, we're talking about the original function, is 2. So this is the coordinate point 1, 2. Therefore, there's my 1, 2 right here. So this is the coordinate point 1, 2. And f prime of 1 equals -2. Again, I go up to my curve, and I look at x equals 1, and this equals -2. That means the slope is -2 at 1. All right, and the equation of the line is simply point slope right there. Okay, so that's my problem. All right, C. This is what we're talking about with this function. We're talking about when we're looking at this problem right here. That's equivalent to f prime of 2. That's what that's saying. Okay? And this is equivalent to f prime of 3. In other words, what is the slope at 3? F prime of 2 is equal to 1. We have that written right down here. Well, and all we're doing is we're going back to the original. And at 2, this registers a 1. So at 2, registers a 1. And f prime of 3 does not exist because it's not differentiable at 3. It's not differentiable at 3. Number 1, because the graph has a sharp curve at 3. You can't tell me how much is changing at that point. If we're looking at the derivative graph, it's undefined at that point. It doesn't exist at that point. There's no value that holds that. Okay. Part D, let g be the function defined by g of x equals e to the x f of x. Find g prime of 0. So this is a couple things. We're going to find the product rule. So in this case, this becomes the derivative of the first, which is e to the x normal second, plus the derivative of the second normal first. That is our product rule. That is g prime. And then we evaluate that at 0. We evaluate this at 0, it equals 1. F of 0 we know to be 3, plus e to the 0 again, which is 1, and f prime of 0 we know to be 1. Therefore, this becomes 3 plus 1, or 4. All right, last problem, number 6. Okay, number 6, we're given a table of values, number of passengers aboard the ship modeled by differentiable function. Notice that this goes from 0 to 1 to 3 to 6 to 8. So my increments are 1, 2, 3, and 2. There's nothing wrong with that. We can take any bottom measurements, all the things we work on, Riemann sums, trapezoid rule, midpoint rule, in this case, average rate of change, all still apply, even though it's not incremental, even though it's not the same rate of change. Okay, so according to the model, what is the average rate at which the passengers board the ship in passengers per hour? So from 1 to 8. So we are doing change in y over change in x. P of 8 minus P of 1, all divided by 8 minus 1, or 728 minus, we're doing 1, remember not 0, 35, equals 99. Divided by 7 equals 99. All right, so don't overthink those problems. Don't overthink these little pieces. All right, the next one asks us to write P prime of 4.5 as a limit of the difference quotient. There's two ways we can do this. We can do it as t approaches 4.5, which makes my denominator t minus 4.5. My original function is p of t minus p of 4.5. This is the first would be 0. There's no first or second or right or wrong, but that would be, a way to look at it. That's the direct valuation. In this case, this is more of our traditional way where we have p prime of 4.5. Our original value is 4.5. Our h is changing here, being added here. We're dividing by our h, and our limit is as h goes to 0. So if I have h in my denominator, my limit is h goes to 0. If I have something like this, t minus 4.5 or x minus 3 or something like that, then my limit is that variable going to that same value. So really this limit is going to make my denominator go to 0. That's the big key. All right. Then from here, I need to use, it says show the computation lead chance, use the data in the table. So I go up here, and I'm looking for 4.5, so I'm looking for right in there. I'm looking for in between this one. So I need to do p of 6 minus p of 3, all divided by 6 minus 3. P of 6 minus P of 3, all divided by 6 minus 3. From the table, we have 600 minus 204 over 3, which gives us 132. All right, last two pieces. Must there be a time, we talked about this today, must there be a time, t, between and including 3 to 6, at which P of t equals 500, okay? So we go back to our values, and we evaluate P of 3, and we see what P of 3 would be. And then we evaluate P of 6, and we find out what P of 6 would be. So P of 3 is 204, and P of 6 is 600. And the question is, why does it equal 500? Well, if I'm just looking at that, yes, it equals 500, but that is not a sufficient answer. I need to say that this is a continuous function. But I'm not given that it's a continuous function. I am given that it is a blah, blah, blah. Where does it say? It's a differential function. It's a differentiable function. Okay? So it's a function where I can take the derivative. If it's differentiable, then it is continuous. Differentiability implies continuity. So because P is differentiable, P is also continuous. And because it's continuous, that means the intermediate value theorem applies, right? And because we have 204 here, and we have 600 here, then 500 lands between there. Therefore, by the intermediate value theorem, there must be at least one time such that P of t equals 500. Okay, last one. We're talking about the total number of gallons used. They give us a function, g of t. They ask us to find g prime of 4. Don't overthink it. Don't freak out about it. Really understand this is very simply a derivative problem. But the biggest key here, yes, we could use the product rule here, but that's a much more difficult process. The bigger key here is to use our rules of exponents, multiply them together, and get 120t to the 3 halves. Then our derivative simply becomes my exponent, 3 halves times 120. So 120 divided by 2 times 3 is 180, and then subtracting 1. Then we evaluate this at 4. Now 4 to the 1/2 is the same thing as the square root of 4, so 2. So 180 times 2 is 360. The key being we need to write down the words.